Okay, guys, finally, now I will explain the TLS 1.3 handshake. The handshake's purpose is for Mr. JP and Mr. YouTube to agree on a shared public key and AEAD algorithm to use. For example, they can decide on SHA-SHA-20 and Poly 1305, the one I just explained. Okay, so let's visualize it. First step is a client hello message from the client. This message will include supported versions, for example TLS 1.2 and TLS 1.3. Normally, all clients supporting TLS 1.3 will also support TLS 1.2 for backward compatibility. Of course, we will also have a list of supported cipher suites. Remember, in TLS 1.3, there are only 5 possible cipher suites, and all of them are AEAD algorithms. Next, we have supported groups, which is a list of valid parameters used for key exchange, whether we use Diffie-Hellman or elliptic curve Diffie-Hellman. These valid parameters can be of two types. First, finite field groups for Diffie-Hellman ephemeral. Those are predefined sets of parameters which can be used for Diffie-Hellman. Next, we have elliptic curve groups, which are used obviously for elliptic curve Diffie-Hellman. Key share will include the public key params used for both Diffie-Hellman ephemeral and elliptic curve Diffie-Hellman ephemeral. In the case of Diffie-Hellman ephemeral, we will have GP, which is a large prime number, and, well, of course, the public key. And by the way, the client on purpose sends the public key params of both Diffie-Hellman ephemeral and elliptic curve Diffie-Hellman ephemeral for the server to choose on its own one of them. Last but not least, the client hello message will include a list of supported signature algorithms. Based on this field, the server will pick a signature algorithm to use for generating the message authentication code of the handshake. When the server receives the client hello message, it will reply with a server hello message. This message will contain the selected version, the selected cipher suite, the selected key exchange group, the server's key share, the server's digital certificate, and the server finish. The server finish will be a message authentication code of the whole handshake up to this point, using one of the signature algorithms supported by the client. Okay, now the client will have two things to verify. First, it will verify the certificate of the server referring to the chain of trust. Second, it will verify the message authentication code received from the server. Finally, the client finished message is sent. The client finished message also contains the message authentication code of the whole handshake until that point. Now, from this point, both the client and the server can start communicating by encrypting messages with SHA-SHA-20 poly 1305.